Okay, let's look at the calculator paper. So just slightly more marks in the wrong calc. We've got 50 versus 40. A little bit longer as well, but an hour and a half versus about an hour. So don't forget, we've got a formula sheet. We'll probably use that a bit more than before. So yeah, let's crack on. So as a tradition, we're usually starting with breaking out brackets, fractions, percentages, functions, the kind of easier topics. So we should think here this is a compound question because I've got a time and I've got a percentage. So I'm thinking it's going to be amount. Yeah, it's going to be this. So my amount is 240,000, just shy of a 250,000, and it's a rise, so it's 1 plus 2.8 over 100, and it's 2 years power of 2. So some people jump straight into this line, so 1.028 to the power of 2. That's fine, but this way you're not going to make the silly mistake of doing 1.28, which people will do, but that would be a 28% increase, okay? So this way, this equation, you're never going to make that mistake. But if you want to, you can go straight to this line. That's totally fine. And there's no marks for rounding in this one. Sometimes it says 3 significant figures, but we should just end up with 253,628.16 pounds. So if it did want it to 3 significant figures, that would be 1, 2, 3, cut it off there. So that'd be 254 because I'm rounding up, and then I need 3 zeros for place value. So just as a wee extra, if you wanted it to 3 significant figures, make sure you do what the calculator says and then round it. Find your place, look next door, 5 or greater, add 1 more. Yeah, nice easy question. This is a slightly harder version. So sometimes it says something like, f negative 2, which would mean you're going to substitute in negative 2. So, okay, that would give you negative 6 plus 2, so that's going to give you negative 4. Fair play. But this one's saying, no, we're going to substitute in a. So f of a, if I put in a instead of x, I've got 3a plus 2. And I know that is going to equal 23. Okay, so the actual y value, the final answer will be 23. So, I think I'll leave it like, I'll then just maybe write another answer. I'd maybe say that, if I was doing it, to be fair. Okay. So f of a is 23. And we're rearranging. 21 is 3a, so a is equal to 7. So nice easy questions to get started with, just to get you warmed up. Yeah. Question 3. We've got a triangle. It's not a right angle triangle, so you should be thinking it's the sine rule or the cosine rule. Now we're trying to find angle as our length AB. So I now don't need to write that because I've just put an X on there. So how do I know it's sine or cosine? Well, we use the cosine rule when there are 3 sides mentioned. Even if one of them isn't known, it's still 3 sides. So check your formula sheet. B squared plus C squared minus 2BC cos A. So you're given that. And the only thing you need to know is that if that's A and that's A, that means they're opposite each other. So if that's the length we're trying to find, we have to use this angle opposite. That's the only stipulation with the cosine rule. These can be B or C, it doesn't matter. That angle is opposite that side, in the same way that angle B is opposite side B. So if we called that B, that would be angle B. Yeah. Anyway, let's substitute in. So A squared, I'm going to call it 1.2 squared plus 1.35 squared. I'm just going to zoom in a bit. I think it's easier to write when I'm zoomed in. Just a little bit more. Take away 2 times 1.2 times 1.35 times cos of 35. And I'll just put that in a little bracket as well. Okay. So that's going to come out, A squared is going to come out as 0.608. And my A is going to come out as 0.78. So don't forget you need to do the square root of this. Yeah, square root both sides to get your final answer. And just don't forget units as well. So you're getting a mark for your substitution. You're getting a mark for this and then a mark for this. Not too bad at all. So when you see non-right angle triangles, you should be thinking sine rule, cosine rule. 3 sides and it's a cosine rule question. Nice. This has been taken out. This has been taken out, so we'll go straight to question 6. People don't like these questions, and they're not my favourite actually, to be honest. But if you just take your time, they make lots of sense, okay? So the Earth is spherical, approximately, and the radius is that. Okay, calculate the volume of the Earth Oh, actually, this I was thinking part B. Yeah, so the volume of a sphere. Again, you're given that volume equation at the front. 4/3 pi r cubed, not pi r squared, pi r cubed. And what's my radius? My radius is just 6400 kilometers. So make sure you cube that. So get your calculator out. So far, nothing difficult. We're just substituting into our formula, and we should end up with 1.098 to the power of 12. You can set your calculator to scientific notation. That's totally fine. And we wanted two significant figures. So there's two significant figures. So find your place next door. I'm going to have to round that up to 1, but then I'm not going to write anything else. And then times 10 to the 12. And that's going to give me kilometers, if the thing writes it, cubed. Area square area, volume would be in cubes. So for that one, question 6, you're getting your marks for just a substitution. A mark for that's pretty good. Mark for this, mark for this. So you put your calculator into scientific notation, so don't stress about that. And don't forget to answer the question fully. Sometimes a good strategy is to tick off things that you use in the question, just to make sure that you don't miss anything out. And so it's this next bit I was thinking people don't like this. So it says that the moon is 2.2 times 10 to the 10 cubic kilometers. Okay. How many times the Earth's volume is greater than the moon? Okay, so the Earth is 1.1 times 10 to the 12 kilometers cubed. How many more times? So if this was nice numbers, okay, imagine the moon was, 10, units, and this was 50. You would simply be saying, well, how many times greater is the Earth's volume than the moon? You'd be saying, well, it's 5, isn't it? It's this divided by this. So try and think of something that kind of makes sense, and then you can use the numbers, the big numbers. So 1.1 times 10 to the 12 divided by 2.2 times 10 to the 10. So that's when people start going, what am I doing? Because the numbers are so weird. But if you see some numbers it makes sense to you. So just think on that. And in a calculator, you're going to find that comes out as it's 50 times bigger. So you're going to mark for setting up your sum and a mark for your final answer. But yeah, I can understand why people don't like these questions because the numbers are so big, it's hard to get your head around. But just think on it with easy numbers, and then yeah, just apply that. Question 7, we'll try and get this one done. So for dividing, I'm keeping the first one the same. I'm changing my sign, and then I'm flipping, and then you're looking to see what you can cancel out. So I can cancel out a T and T from here. I can cancel out an S and an S from here. So I'm going to end up with just 10S. Multiply the top, multiply the bottom. So for that one, you're getting a mark for your keep, flip, change. Give yourself a tick. You then get a mark as you start to multiply things together, and a mark for your cancelling out. So actually, if you multiply it together, you get another mark and then cancel. But I've just cancelled first because I find that a little bit easier. Let's probably manage this as well. Original price. So the first thing you're saying is 297.50 is equal to what? Well, it was 100%, but the discount in the sale was 15, so it's now 85%, isn't it? It was 100, it's been reduced by 15, so that's 85. So what we do with our calculator is find 1% and then find 100%. So to do that, I need to divide both sides by 85, and then I times by 100. So get your calculator out. So 1% is going to be 3.5. I divide that by 85 times by 100 for £350. So you're getting a mark each point of the way. Mark, mark, and a mark. Yeah. So your first bit, just get that right. We always start at 100 and then either add or we're taking away. In this case, we're taking away 15. And then what we do to one side, we do to the other side. So divide that by 85, multiply by 100. Great question. So those are the two big percent questions. This one and your compound. Your compound's got a time in it as well. So if you don't see a time in percentages, you're thinking it's a reverse to change. So yeah, so far I've got reverse to change, got a bit of fractions, some scientific notation and volume, cosine rule, functions, and our percentages. So far not too bad actually. Nice little start to the paper. And the question 9 is no longer in it, so I'll start the next one from question 10.